Hey everybody, it's Coach Scott, and it's I'm going to start working on stoichiometry, and this is from homework sheet 4D, the one on stoichiometry. And if you look here at your worksheet, it says here, consider the following unbalanced combustion equation. So again, we got a hydrocarbon, it's burned in oxygen, it yields CO2 and water, dihydrogen monoxide. So you see these a lot. Y'all hear Lucy? Yeah, she's getting loud. So we got to balance it. So let's start right here by adding a 7 right there, right? And that's going to give me, let's see, I've got 7 carbons on that side, 7 on this side, 16, 2 oxygens. I got 14, 15 oxygens here. Let's worry about the hydrogen. So I'm going to put an 8 there. That stands for 8 moles of hydrogen. So now I've got 7, 7, 16, 16. I've got 2. I got 14 and 8. 14 and 8 is 22. So now if I put on an 11 right here, I've got a balanced reaction. 1 mole. Let me get her out. Sorry guys, she was doing the Lucy dance, so we had to let her go. So anyway, our question here, and this is where the stoichiometry gets good, is how many grams of heptane, C7H16, will react with exactly 0.4782 grams of oxygen gas. 0.4782 grams of oxygen gas. Well, that's not the one I wanted. That's the one I wanted. That one there. So I've got oxygen, I've got heptane, C7H16. So, and then I've got my magic little formulas here, right? So if I start, I've got grams, all right? It wants grams. All the magic happens when we take things into moles, all right? So I'm going to have to convert the oxygen into moles, and we know how to do that. So I'm going to use dimensional analysis, 0.4782 grams, and man, this is writing slow, of O2. To get the number of moles, what do? We multiply by the atomic mass, right? All right, or divide by. So I have 1 mole of O2 equals what? Let's look here, and we got to look at the periodic table. Oxygen is 15.999. I've got 2 of them, so now I've got to do some math. So I'm going to do some math. 15.999 times 2 is 31.98. And because now I want to be as accurate as I can, I put it all in there. 31.98 grams of oxygen, O2. All right, and that's going to give me how many moles? All right, 31.98, 0.4782 divided by 0.98. That's going to give me, there you go, 0.01495 moles. All right, and how do I know that? Because if I cancel out grams, I cancel out grams of O2, I'm good to go. So now let's take this here. I know how many moles of O2. All right, 0.01495 moles O2. All right. So now I've got to do that magic thing called the mole ratio. And let's look at our ratio. For 11 moles of O2, all right, 1 mole of C7H16 will react. So I need 11 moles O2. So let's put our ratio here, 11 moles. Mole O2. All right. It's going to give me 1 mole of C7H16. Let's do our math. And let's see. So we're going to do 7, let's look right here, times 12.011. Because I've got 7 atoms of carbon. Plus, how much is hydrogen? Let's look here on the periodic table. Hydrogen is 1.008. So that'd be 16 times 1.008. Sum it up, and I get 100.205 moles. No, excuse me. We'll need that again. I messed up. I was getting the molar mass of C7H16. So only because I got it, I'm going to write that down up here. C7H16 equals 100.205 grams per mole. All right, let's do what we were doing. So I got 0.01495 divided by 11, because for every 11 moles of O2, 1 mole of C7H16 is needed. And there, I get 0.001359. And that's moles of C7H16, because moles of O2 were crossed out. Okay. So now I'll be able to get the grams. All right, so now I've got, I've got 0, oh, there we go, 0.0001359 moles of C7H16. And they want grams, so now I've got to use the gram molecular weight or the atomic weight to find out what I got. So for every 1 mole of C7H16 has a mass up here, right there, 100.205 grams times 1.59. Whoa. So now that means that when those react, we're going to have 1.8 0.47, because I had four significant figures up there. That's what I'm going to report. Times 10 to the minus 6 grams. That's not a lot. That's C7, H16. All right. B is very similar to A, but now we're going to use 0.4782 grams of O2 gas. Okay, and then we're going to use the magic molar ratio using CO2, and I'll film that later on. So this is Coach Scott. I'm going to let you go with that one. That's 1A of worksheet 4D.